In this video, we will discuss one more example of inductive proof that we are going to solve using principle of mathematical induction. Let P of n is equal to 1 plus 4 plus 7 plus up to 3n minus 2 is equal to n into 3n minus 1 divided by 2. Call it as equation number 1. We have to prove that for any value of n, given statement is true. We know that mathematical induction works in 3 steps. First step is a basic step where we are trying to prove it for n is equal to 1, that given statement is true for the minimum value of n. Then we assume that it is true for some n is equal to k, and then from those assumptions we will try to prove that it is true for some n is equal to k plus 1 as well. If we can do that, then the given statement would be true for any random value of n. Consider n is equal to 1. So left hand side would be 1 only, because if we put the values into this equation, that would result into 1 only. That means or we have to take only the first value of this entire sequence. So that is 1. On right hand side, if we replace n by 1, then that would be 1 into 3 into 1 minus 1 divided by 2. So ultimately that is also 1. So here we can see that LHS is equal to RHS, and hence it is true for P of 1. Next step is inductive hypothesis. We are assuming that for n is equal to k, given claim is true. So from equation 1 we can write that 1 plus 4 plus 7 plus 3k minus 2 is equal to k into 3k minus 1 divided by 2. So n we have to replace by k in equation number 1. Now in induction step, we have to prove that it is true for n is equal to k plus 1 as well. So replace n by k plus 1. That means you go into this series up to k plus 1. So first k plus 1 steps of the series given in equation 1 we have to write down. So that would be 1 plus 4 plus 7 up to. Then kth step would be 3k minus 2 plus the k plus first step would be n we have to replace by k plus 1. So that would be 3 into k plus 1 minus 2 is equal to, in right hand side also k n would be replaced by k plus 1. So that should be k plus 1 into 3 times k plus 1 minus 1 by 2. Right? This we need to prove. If both the sides are same, then it is true. Or we can say it's proved for any value of n. So there are two approaches. Either I will start with left hand side and I will derive the right hand side, or another way is that I will process both the sides simultaneously. I'll simplify both the sides, and some stage I will show that okay, these both are same. So here the second approach would be better. So from equation 2 I can see that red part in equation 3 I can replace by the blue one of equation 2 because they both are same. That assumption we have already made in equation 2, that summation up to 3k minus 2 is equivalent to k into 3k minus 1 divided by 2. So that is just a replacement. On right hand side we are just simplifying it. So it would be k plus 1, then we are multiplying 3 inside. So that would be 3k plus 3 minus 1. So ultimately that is 3k plus 2, and the term is divided by 2. In left hand side term of this equation, the first part or first half is divided by 2, but second one is not. So to simplify it, we will multiply the second part by 2 and we'll divide it by 2, so that we can have a 2 common in a denominator, and that 2 will be cancelled out because we have a 2 in denominator on both the side, left hand side as well as right hand side. So we can drop that 2. So after simplification we have k into 3k minus 1, and then we need to multiply the second term by 2 because that 2 was not in the denominator of that. So that is 2, 3k plus 1 is equal to k plus 1, 3k plus 2. So 2 we have dropped from both the sides from the denominator. Fine. Let us simplify it. So we are multiplying k inside here. So that would be 3k square minus k, multiply 2 inside. So that would be 6k plus 2. Same way on right hand side also we are multiplying k inside first. So that would become 3k square plus 2k, and then multiply it with by 1. So that is 3k plus 2. Further simplifying on this, we will get 3k square plus 5k plus 2 on left hand side, and on right hand side also we have 3k square plus 5k plus 2. That says that whatever we have assumed in equation number 3, it is proved. The left hand side is same as the right hand side. So it is proved that the given claim is true for some n is equal to k plus 1 also. And hence the induction hypothesis holds, and we can say that given statement p of n is true for any value of n. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel Code Crafts. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.